Assalamualaikum dan selamat sejahtera. Hari ini kita akan belajar chapter 1.1 Molecular and Structural Formula. Okay, at the end of the lesson, you should be able to define what is structural formula, draw structural formula, okay, whether it is expanded, condensed, or skeletal structure based on the molecular formula. So you should also know what is molecular formula. Identify classes of carbon, primary, secondary, tertiary, quaternary, and also for hydrogen. Okay, actually the ability to draw organic compound structure is the basic skill needed to understand organic chemistry. So you need to be able to draw the structural formula. So shown here for you is structural formula, which is a formula that shows how the atom in a molecule are bonded to each other. For example, this carbon. This carbon is attached to 3 hydrogen. Okay, and one more to another carbon. So it have 4 covalent bonding. So carbon, as you can see, always have 4 bonding. Second carbon, this is carbon number 1. This is carbon number 2. 1, 2, 3, 4. The same thing for this one. 4 covalent bonding, carbon, 4 covalent bonding. There are 3 types of structural formula. Expanded structure. This is expanded structure. The one that shown for you here is expanded structure. Condensed structure. This one, condensed. And skeletal structure. Okay, only the skeletal is shown, bond line formula. Okay, expanded structure. It shows all the covalent bond between the atom, not representation of the actual shape of the molecule. Okay, let's see, for example, this one, expanded structure. Okay, how can we draw expanded structure for this one? Molecular formula is given. So we can draw molecular structure for this one, C4, so draw 4 carbon. Okay, 4 carbon. And it can have hydrogen at this part. Okay, hydrogen. Okay, remember there is also Cl. We can put Cl anywhere. Maybe here, maybe this part, maybe this part, maybe at the end. As long as it is only one Cl that you want to add. Okay, so this is expanded structure. Okay, why is this expanded structure? Because it shows all the covalent bonding. Okay, carbon attached to hydrogen. This one, hydrogen attached to carbon. It shows all the covalent bonding. So let's see the actual answer. Okay, the same. Okay, so that is expanded structure. There are 4 carbon. And this one is butane. We are not going to learn about naming yet, but let's just proceed with this one. Okay, butane, because it is 4 carbon, you should remember that one carbon is methane, second one is ethane. If it have 3 carbon, it is propane, butane, and then pentane, and so on. Okay, Cl. So this one is chloro attached to carbon number 2, so 2-chlorobutane. Okay, expanded structure. Alcohol. Okay, what about alcohol? Expanded structure. So 2 carbon. So you should know that carbon for alcohol, it should have OH. So this one, 2 H hydroxyl group. Okay, and then we try to calculate again the number of carbon, hydrogen, and oxygen. So carbon is 2. Okay, correct. Hydrogen should be 6. 1, 2, 3, 4, 5, 6. So correct. And oxygen is 1. Okay, so this should be alcohol. So let's see the answer for it. Okay, the same. So this is alcohol, expanded structure. Carboxylic acid. Okay, for carboxylic acid, the functional group is C double bond O OH. Okay, so you already use 1 carbon, so it leave you 2 more carbon. Okay, and each carbon should be 4 covalent bonding, so you should fill this up with 3 more hydrogen. So this is also hydrogen. What about this one? 1, 2, 3, 4. Okay, already complete 4. So let's count again. Carbon, is it 3? 1, 2, 3. Okay, correct. Hydrogen, is it 6? 1, 2, 3, 4, 5, 6. Okay, correct. Oxygen, is it 2? 1, 2. Okay, also correct. So let's see the actual answer. Okay, so the same. Okay, expanded structure. So let's try to draw this one. Write an expanded structure for each of the following hydrocarbon. Okay, given for you, propane. Propene, one clue that is given for you, it have one double bond. Propene or propine have one triple bond, and cyclopropane have cyclic structure. So it means that propane here is all single bond. Okay, let's try to solve this one. Okay, propane, methane, ethane, propane. So propane should have 3 carbon. So 3 carbon, so C, C, C. Okay, and complete all the covalent bonding. So this should be propane, all single bonding. C single bonding with C, C single bonding with C, and all are single bond. Okay, so that is the answer. Okay, propane. Propane, the clue given for you earlier is double bond. So C double bond C and single bond C. Only one double bond. And complete the number of the hydrogen. 1, 2, 3, 4. Okay, this carbon have already 3 bonding, so you should add one more hydrogen, and this one C only have 1 bonding, so it should have 3 hydrogen. So that is propane. Okay, it should be correct. Okay, the same with my drawing. Okay, what about propine? Propine, still 3 carbon, but the clue given for you, it have triple bonding. Okay, still 3 carbon, propine, but one is 3 carbon. So complete the number of hydrogen. So this one should have only one more hydrogen, because it already have 3 covalent bond. And this carbon at the center have 1, 2, 3, 4 covalent bond already, so no more hydrogen to be added, whereby this one should have 3 more hydrogen. Okay, so that is for propine. Okay, so the same with my drawing. Okay, cyclopropane. Cyclopropane is a cyclic structure built up with 3 carbon, because propane still refers to alkane that have 3 carbon. So let's draw like this: C, 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 and count again the bonding. This carbon already have 2, so add 2 more. This one also add 2 more, and this one also add 2 more. So that is the structure of cyclopropane. Okay, the same with my drawing. Okay, next, condensed structure. It does not show single bond. Okay, it does not show single bond, but for cyclic compound, you still draw the single bond. If it is not cyclic structure, means linear structure, you show the double and triple bond, but not single bond. Okay, all atoms that are attached to a carbon are written immediately after that carbon. Okay, what does this mean? Okay, let's say I have a structure like this: CH3, CH3. So if I want to draw a condensed structure, I will draw like this: CH3, and because this carbon appear next to this carbon, immediately after this carbon, so CH3, CH3. Okay, so it means that this carbon attached to this carbon are written immediately after that carbon. Okay, it doesn't matter lah. It can also be Cl. If I have, let's say, CHCl. Okay, so this one I will write down CH3. Okay, I group them together. CH2. Okay, this is CH2, and Cl. Okay, all atoms that are attached to a carbon are written immediately after that carbon. This Cl attached directly to this carbon. Okay, so that's why I draw Cl next to this one. I cannot draw this CH3 Cl CH2. This one is wrong, this one is correct, because it means that this Cl is actually attached to this carbon. Okay, when I draw like this, it means that this Cl attached to the second carbon. This is carbon number 1, carbon number 2. Let's say it is like that lah. Okay. Okay, example, C4H9Cl. Okay, so you can draw like this. Earlier we know that Cl attached to carbon number 2. If you refer to the previous expanded structure of C4H9Cl. But actually this Cl can also be attached at the end, maybe here, or maybe at this part. For this example, it shows that Cl is attached at carbon number 2. So that is condensed structure. Okay, carbon attached with 3 hydrogen is grouped together as CH3. Okay, so let's try this one. Cyclohexane. Cyclo means cyclic structure. Hexane means alkane that have 6 carbon. So let's try to draw this one. Condensed. CH2. Okay, supposedly I draw. Okay, I draw roughly the shape first. So easier for you to understand. C hexagon. The shape is hexagon. C. Okay, so this the shape of cyclohexane. But this one is condensed structure. As I told you earlier, condensed structure, we does not need to show single bond. But for cyclic compound, this is cyclic compound, we still need to show the single bond. So condense this part, CH2, because this carbon already have 2 covalent bonding. So the rest of it should have 2 more hydrogen. The same thing for this one, 2 bonding. So CH2. You can also write down like this, CH2C, because it means this carbon have 2 hydrogen attached to it. And also like this. Okay, so that is cyclohexane. Okay, let's see the actual drawing. Okay, so the same. Okay, this one. Okay, so you can transfer this into drawing CH3. Okay, all these are CH3. And this one is CH2. This part is CH2. And I can group this one all together to become COOH. COOH is actually functional group. So you can group them together, COOH, like this. Because we know it is carboxylic acid functional group. Okay, so the same with my writing here. Okay, what about the use of bracket in condensed structure? To show the thing at the side chain. Okay, anything that attached to the side chain, usually we put a bracket. Okay, this is bracket. So let's see the example. For example, this one, propane to ol. Propane to ol refers to ol here refers to alcohol. Alcohol have this functional group OH, so it means that OH attached to carbon number 2. Okay, so this is propanol. 1, 2, 3, carbon number 1, carbon number 2, carbon number 3. So OH, okay, OH here is attached to carbon number 2. So for you to draw the condensed structure, you can draw CH3. Why CH3? Because this is one, the one that you group together, carbon that you group together. CH, and this one you can draw OH and CH3. Okay, another group of CH3 is this one. This one is CH at the center. CH at the center here. Okay, but earlier we say we didn't draw single bond, right? But this is single bond. So how can we eliminate this single bond? But actually this is correct for condensed structure. So for you to eliminate this single bond, we write down like this: CH3 CH OH CH3. So we are using bracket. Okay, so the bracket is actually to show what are the things that attach to the side chain. So this is side chain. Okay, this is side chain. Okay, if this one is side chain, what chain do we call this one? Okay, this is actually what we call not main chain, parent chain. Okay, this is parent chain. The longest chain is called parent chain. Anything that attached to the parent chain is called side chain. Okay. So let's see. What are the few other kind of condensed structure that you can write? So that is expanded. So you can write down like this, or without the bracket. Also correct. Or like this. Okay, this one is interesting. Okay, this one, it means that you have two similar group attached to the same carbon. Okay, these two things are similar. CH3, CH3. Okay, similar group attached to the same carbon. This one also attached to carbon number 2. This one attached to carbon number 2. So that's why we can group them together. CH32. It means there are two group of CH3 attached to the same carbon. Okay, and one more is OH. Okay, OH also attached to carbon number 2. And remember, all these are correct. All structures here are acceptable. Okay, more explanation about the bracket. Okay, what about this one? Okay, this one, if you look closely, you can see that there are three similar structure. Okay, these are all three similar structure. Okay, so if you have three similar group, you can write down like this. See, okay, so bracket CH3 3 3 CH. Okay, it means that there are three methyl group, three similar group attached to the same carbon. If you expand, the structure will be like this, or you can also write down like this: CH3 CH CH3 CH3. Also correct. This one also correct. Or you can write down with the bracket CH3 CH CH3 CH3. Also correct. Okay, or you can group them together like this. Okay, so let's see the actual answer. Bracket I use around similar alkyl group bonded to the same atom. This is what I say, similar group attached to the same carbon. Okay, so condensed structure, it can be like this. And that is the use of bracket in condensed structure. It can also use to indicate repeating structure. Okay, for example, octane here. Okay, repeating structure. Okay, so repeating structure is this part, CH2 CH2. Okay, how many times this one is being repeated? So we need to calculate. Okay, so this one is repeated 1 2 3 4 5 6. Okay, CH2 is being repeated 6 times. So you can actually group this one for condensed structure CH3 and then write down CH2 6, and one more is this one, CH3. Okay, this one we know that CH2 is being repeated 6 times. If you expand this structure, it will show the expanded structure like this one, like this octane drawn. Okay, so let's see the actual answer. Okay, or you can simplify like this. Okay, this one is correct, this one is also correct. Which one is easier? The one that is easier is the one that you understand. Choose the one that you understand. Okay, for single atom as halogens, no need to put bracket. Yeah. Okay, for example earlier this one, so no need to use bracket. But I think even if you put bracket, you are still not wrong. You are still not wrong. We can accept that. Okay, so this is condensed structure. All are acceptable. Carbon attached to carbon number 2. Chlorine attached to carbon number 2. Carbon number 1, carbon number 2, carbon number 3. So that is the use of bracket. Okay, so let's try this one. Okay, so how can we draw the condensed structure? Okay, if you look closely, there are two similar groups at this part. Okay, so you can write down CH3 to CH. Okay, CH is this part because 2CH3 attached to the same carbon, this carbon, but this carbon also have one H. So next one we have C, whereby it have 2Cl and CH3. Okay, or you can also write down CH3 to CH, C, Cl, Cl, CH3. Okay, this one acceptable, this one also acceptable. Okay, condensed structure. Okay, so that one or this one. Make sure double check the number of carbon. So 1, 2, 3, 4, 5. So 1, 2, because you write down 2, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. Betul, bukan 6. 1, 2, 3, 4, 5. 5, betul. 1, 2, 3, 4, 5. Okay. So make sure the carbon is correct. Do not have extra or do not have less carbon than what it is should be. Or this one also acceptable. Okay, what about this one? This one you can write down CH3 CH. Okay, you can put bracket if you want for this one. C Cl. Oh, sorry. There is H. Okay, I put H here. Oops. H and CH. CH3. Okay. Okay, you need to be able to group them together. Okay, this one is this one. CH here is this part. Okay, OH is attached to the carbon number 2. So OH is attached to this carbon. CH, CH, and Cl attached to carbon that is before it. And this one is this one. Okay, so I hope you can see that. Okay, it can be this one or without the bracket, because every time you write down a functional group or any atom like this, it means this one attached before it, this one attached to the carbon before it. Okay, so we should understand that. Or you can draw like this. All are accepted. Okay, next one, skeletal structure. Okay, skeletal structure is the easiest to draw but hardest to understand. Shows only the carbon skeleton. Carbon chain are drawn in zigzag. C atom is seen to be at the end. C atom are usually not shown. Each atom bonded to C are not shown. Functional group are shown. You will see better. I think you will understand better when we see the drawing. Okay, let's draw for us to understand this one. Okay, for this one, Carbon is not drawn. Carbon is not drawn. So what is drawn is the functional group only. And what is drawn is only the skeletal structure of the carbon in zigzag. So for this one, how many carbon are there? 4. 1, 2, 3, 4. So we can draw 1, 1, 1, 2, 3, 4. Okay, each end and intersection here refers to carbon. So there are 4 carbon. 1, 2, 3, 4. Carbon number 1, carbon number 2, carbon number 3, carbon number 4. Carbon 1, carbon 2, carbon 3, carbon 4. And one methyl attached to carbon number 2. So this is what I draw. Okay. Let's see the answer for this one. Okay, so the same. One more thing. It also doesn't matter whether you want to draw it like this or you start at the bottom first. 1, 2, 3, 4. Like this. It's the same. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4. Okay, carbon number 1, carbon number 2, carbon number 3, carbon number 4. It doesn't matter whether you want to start at the top like this or you want to start at the bottom like this. Doesn't matter. Okay, what about this one? Single bond is shown, carbon is not shown, and double bond we have here. So 1, 2, 3, 4. Okay, draw the longest chain first, and there is one Cl here. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, let me just label so that we can see. 3, 4. Okay, and at carbon number 4 there is Cl attached to it. So that's why we need to draw like this, because every intersection refers to carbon. This one does not refers to carbon because you write down Cl. It means that this one attached to Cl. And double bond between carbon number 2 and carbon number 3. So this is the part that you need to draw. Double bond. So there is double bond and methyl group attached to carbon number 2. Okay, so that is the structure. Okay, correct. So let's see. Let's compare 1, 2, 3, 4. Okay, so similar to what I draw. So that is skeletal structure. Okay, so every end and every intersection is the carbon, atom. Okay, unless you put something here. For example, this one at the end here you put Cl, so it is not carbon lah. It is Cl. Okay. Oh. Okay, what about this one? Expanded structure. Okay, for expanded structure, you can draw skeletal like this. Okay, remember when you draw, do not make extra edges. Okay, for example, if you want to draw this quickly, it will be like this. Maybe it will become like this. Okay, this means that there is extra carbon. So we do not want you to draw like that, or you draw like this. Okay, this one it is not attached. Okay, so you need to draw carefully. For this one, better if you draw without lifting your pen carefully like this, without lifting the pen. Okay, so this one should be better chemically. Maybe you draw it not pretty enough, but it's okay as long as it is chemically correct. Okay, so you can put OH here. You can put OH at any part of this as long as it is the same. So it means that this one, or you draw like this, OH also okay, or you draw OH like this also okay. Make sure the bonding is between O and H. What I mean is that do not draw. Okay, that one is wrong. Do not look at that one. HO like this. This one is wrong, because this one shows that this one attached to H. Okay, this one attached to H. Okay, we do not want that. Okay, so skeletal structure will be like this one. And this one, it is amine, so nitrogen attached to one methyl group, one more methyl group, and 2 carbon. So this one is 2 carbon. So carbon number 1, carbon number 2, carbon number 1, carbon number 2, and this is 1 carbon. So this is 1 carbon, and this is also 1 carbon. Okay, this is not carbon because you write something here. When you write something, it means it is not carbon. So this one is nitrogen. Okay, so let's see, let's compare. Okay, so the same. So that is the structure for expanded structure that we change into skeletal structure. Okay, for next one, pause this video, try to answer it in your paper, and then try to see whether your answer is correct or not. Okay, so pause this video, do it first after you have done question 1, question 2, question 3, and then click play to see the answer. Okay, so here is the answer. The position for this compound doesn't matter. You can also draw like this. Make sure if you want to draw, make sure you draw correctly. Okay, so that's it for today. I hope you get the idea on how to draw condensed structure, expanded structure, and skeletal structure. Okay, that's it for today, and we'll see again. Don't forget to like and subscribe.